Explaining Explainability. In this podcast, we bring together the different disciplines of the Collaborative Research Center Constructing Explainability. Two researchers discuss a concept around explainability from their point of view. Moderated by Prof Britta Wrede.
Welcome to our podcast, Explaining Explainability. This is episode 4, and we are talking about co-construction. So probably everybody who has access to the internet has already tried ChatGPT. And while the first versions showed a lot of problems like hallucinations, things that were incorrect, the current versions have shown incredible improvements, and they are very smooth explainers, actually. And with DeepSeek, we now see even something maybe better, which might be a remedy to hallucinations. So are we done? Has a solution to explainable AI been found that satisfies our requirements for AI, that can explain itself and many other things? As we have discussed in previous episodes, explanations are not delivered in a one-way process. They are co-constructed by the explainer and the explainee in a dialogue, and it seems that LLMs are quite good at doing exactly this. But do they really co-construct? And what is co-construction? To answer these questions, I have today with me two experts for LLMs, Professor Axel Ngonga and Professor Henning Wachsmuth.
Axel Ngonga is full professor of data science at Paderborn University and a co-founder of the startups Databorg AI and Tantris.io. He has over 20 years of experience as a researcher developing algorithms for the knowledge representation, machine learning, and natural language processing. In the Collaborative Research Center, he co-leads the project B01, a dialogue-based approach to explaining machine learning models.
Hello,
Hi.
Axel. Nice to have you here.
Thank you for having me.
Professor Henning Wachsmuth leads the Natural Language Processing Group in the Institute of Artificial Intelligence at Leibniz University Hannover. His research interests within natural language processing include computational argumentation, the detection and mitigation of social bias in language, and the generation of explanations and feedback. He investigates how people express their intentions and views in language and how machines can understand and imitate this using large language models.
Hello, Henning. Welcome.
Hi, thanks for having me too.
So, you have both been working with deep neural networks and with large language models in particular for several years now. But before we discuss in more detail about how they might help with XAI and co-construction, let's first step back a little bit and talk about co-construction and also about your current research in the TRR. So, Henning, what is, from your perspective, co-construction? What makes it so special? And why do you think it is a good idea to target co-construction as a mean to achieve explainable AI?
So co-construction, in my view, describes the idea that when we do something together, for instance, when someone explains something to someone else, this is not a unidirectional process, but both participants in a respective interaction add their part. For instance, if we talk about explaining, then the explainee makes also clear what they have understood, what they are actually interested in. The explainer tries to adjust how they talk to the explainee. They may also react to if they see that the explainee understands something or not understands something. And so it's a dynamic process that ultimately leads to hopefully to understanding or something similar, whatever is meant to be achieved on the explainee side.
Yeah, so we have actually also talked about understanding, which is not such an easy concept. Would you say that the understanding, it is clear from the beginning what should be understood, or is that also part actually of the process?
I mean, I cannot really say that I can answer this unbiased because I have been in the TRR for a few years and apparently learned there and got to be even more convinced that it's part of the explanation process to figure out what is it actually that the explainee wants to understand or needs to understand. And sometimes this is not clear from the beginning, either because it's not expressed clearly or because it's also not clear to the explainee what the explainee doesn't understand. So it only becomes clear through the discussion with the other side.
Yeah,
No, but I would suggest that it is
Well, it is often the case that it is unclear, but there are contexts and situations where the thing that is to be understood is actually very well defined. As if you take, for example, training people to use particular machinery, say in the army, then you know exactly what the person is supposed to be able to do at the end. So there's actually a very clear target of the explanation in that case. But if we talk about general explanation processes within a societal setting, then yes, that's absolutely the case.
So this is very interesting. Sorry.
Granted, he's fully right.
Yeah. That's really interesting what you just said. So it seems to depend on the context, what is good or what is not such a good explanation maybe. In the INF project, you have at least tried or targeted to get a measurement for good explanations. Is that possible? Or how are you trying to measure that?
Yeah, I can tell you different things we tried and are also actually still working on. We had situations where we were already given the full dialogues but couldn't really access the people that explained or that were explained to. So in that case, we try to assess from the outside, can other people, if they look at what happened in the dialogue, actually tell that it looks like the explainee achieved the understanding that was meant to achieve. And we observed there that sometimes that's very clear because it's made very explicit, or even also maybe in the ideal case clarified by the explainee stating something that shows the understanding. But in other cases, you couldn't really tell from what was said, no? Now, currently we are doing a bigger user study also with LLMs. We may come to that later, where we interview the people that interact with an LLM on their understanding, and we do this in different ways. We ask them what they actually think, what they have learned, and how confident they feel now. But we also test their understanding by having topic-related questions that we see if what was meant to be learned is actually learned. So that's a bit the ideas we're pursuing in the DRR.
Okay, so what you're actually doing is then sort of testing explicitly afterwards if they understood, and that is then your measure.
Yes, let's say, of course, it's not a very exact measure. As with any test, you may know this from teaching, you can never really fully assess the understanding properly of students or of explainees in general, but you can at least get to if certain things that should be understood did become clear on the explainees.
Okay, yeah. Would you think it possible, either of you, to just listen, like make an LLM, give the task to an LLM to judge whether or not a dialogue has been a good explanation process? Do you think that is possible?
Well, it really depends on what you call a good explanation process. And currently, LLMs might look like very good explainers from the outside, but internally, I would not suggest that they are if we assume that we are to build co-constructive explanation processes in general. Their mental model of the user is quite limited, if you want to put it that way. So would it be possible? I would suggest that that's not the case yet, simply because I'm not aware of LLMs having good co-construction capabilities, but that's something that needs to be evaluated properly. So that's my current point of view, but I don't have any measurements for that.
I'm actually not fully sure if this is the question you had meant originally, but let me shortly follow up on what Axel said.
Yeah.
One particular problem that there is currently with looking at what LLMs do and being so impressed about it is that people are not used to paying attention to the right things, because LLMs make very different types of errors than what we used to think what machines do, or also what maybe humans do. And we need to learn first how to actually understand what is good and what is bad in the things they answer. I do think, though, your question targeted at whether LLMs can assess if an explanation is good, right?
LLM as judges, I guess, of an explanation process. And my point is really, if you fine-tune an LLM to whatever is good, whatever definition of good you have, then sure, you could do that, at least as a proxy. But current LLMs, if you were to take like an out-of-the-box DeepSeek or Llama 3 or whatever you want to use, I would suggest that would be difficult, simply because this idea of co-constructive explanations is not necessarily a given.
Of course, yeah, I see. Actually, we come to that later again in more depth, and I find it very interesting. And now I would like a little bit to switch to your project on metaphors in C4. You're working on metaphors as, I think, a scaffolding strategy for explanations. Could you a little bit explain what metaphors are and how can you detect what a metaphor is? Can you do that?
You can, at least as always, when it comes to automatic methods to a certain extent. So metaphor is a concept from linguistics originally, in which we project meaning from one domain, that's the so-called source domain, to the domain that we are talking about. That's the so-called target domain. So if I say reading is vacation, I take meaning from the domain of vacation or holidays or so, and I project it onto the domain of reading or maybe books or whatever then the exact domain is. Now, in that project, we studied metaphors first in a very basic way by seeing how does this actually work, how does such a meaning projection work, and can we model that computationally also with methods from natural language processing. Related to this, the question, can we actually detect when metaphors are used in language? And to answer your question on this regard, if we tackle this task explicitly, it's actually usually working very well. Current methods are good in seeing that something is meant figuratively, so metaphor is also a type of figurative language. The bigger problem comes with if we don't tell a model that something may be figurative in a context, but it just has to deal with that language, it more often maybe misconceives what actually happens in that piece of text or language.
Okay, I see. And have you found how metaphors might be helpful in explaining, or what have you found in explanation so far?
Yeah, we are still on this, but we have done a bit studies, particular on how different is metaphor use in different contexts when it comes to explaining. For instance, we looked at situations where we can see how people perceive certain metaphors differently. In a case study, for instance, how people with a different political attitude, let's say, look at metaphors. And for instance, found that liberal people tend to be much more open to the effect that is meant to be achieved by metaphors than conservatives. So such differences also exist, suggesting that metaphors may be useful for certain people, but may not be useful for all people in explanations and beyond.
Okay, so that's really interesting, because of course they could also hinder, right? If they go into the wrong direction, or if it's not understood, it could even stir or cause more irritation, probably, I guess.
Most certainly so, yes, because I think, a metaphor that is not really understood by the explainee how it is actually meant to relate to the thing being explained may rather confuse the person, because you think about the wrong things if you cannot make the connections to what is actually being talked about.
Okay, so you are now analyzing metaphors. Are you also working towards generating metaphors? Would that be interesting?
Yes, that is actually the core idea of our project in the second phase. So the long-term goal always was, can we actually make an AI explainer also, or can we enable it to also explain metaphorically and to decide what metaphor to use, when to use a metaphor, and how to maybe adjust metaphors. And in the second phase, we work towards this. We look at how to actually generate metaphorical explanations, how to adapt them based on understanding or non-understanding.
So that would be interesting, because then you would have to take two domains and somehow bring concepts together from a source domain into a target domain. Sounds interesting.
Yes, of course, as often in AI-related contexts, we usually start from data, and data tells us a lot already about what concepts people connect with each other in the real world, and so we believe that can also be well transferred to automatic methods.
So that's really interesting.
Can I spike your drink for a second and ask a question in the following sense? I actually tried the whole metaphoric thing by using a language pidgin, which is, basically, to be very specific, is southwestern Cameroonian pidgin. And it turned out that the system was really messed up by that and really got absolutely nothing. Do you think that metaphors only make sense if you have an LLM which is really potent in the language at hand.
I'm pretty sure that strongly affects metaphor performance. We looked only at German and English metaphors and also at their differences. And it turns out actually the differences are very small, but it's also to be understood, that these languages somehow have similar roots, at least partly. And yes, LLMs are very good actually in dealing with cross-lingual situations, but that does not mean they can easily solve complex tasks in any language they are prompted for, and particularly a language that is not so well-resourced on the web or wherever LLMs take the data from, that may easily go down in such situations.
Cool.
Yeah, interesting. So this is already a glance into the future. I was wondering, so in BO1, so you have a lot of interesting projects there, but so I just looked into this one, which I found interesting, and I don't even know if it's really your study or Philip's, but anyhow, I found it interesting that there was a study where different types of interaction with an XAI system were compared, and one was free dialogue style, and there were several others, but the one that actually performed best was not the free dialogue, but sort of a chatbot styled button-based interaction, so I think where you could probably click for certain questions, and it turned out that actually led to the best understanding in terms of predicting what the model would do.
Yeah, that was work carried out by Philip Chimiano's team, indeed. So we were not really involved in that, but we've done a similar work, actually asking the question, does free language or controlled vocabularies, what really helps? The main advantage of using a controlled vocabulary, which is really quasi-equivalent to the button style approach, is that the semantics are very clear. So you don't really need to look at a very wide semantic spectrum. You actually look at a very limited semantic spectrum, which means that communication is also way easier, which means there's actually less room for misunderstandings, which leads to very fast explanation processes. So it's actually, if you think about it from a perspective of co-construction, you've already co-constructed the space in which you are, or you've basically told about both parties, this is the semantic space in which you are, and that makes the rest of the process significantly easier. So it's not a surprising result, but it's a great result to have indeed.
Yeah, so that's interesting. And but in how far could then a free dialogue be even better than that?
Well, with restrictions come restrictions, right? So if there is basically, if the explainer or the explainer does not live well in that space, or if your explanation does not live well in that space, or basically the thing which is to be explained, your explanandum, then there is a problem, of course. And the problem is you cannot get out of that free space. Having free dialogue has the main advantage that you have the full spectrum of natural language, and obviously you can navigate towards an explanation way easier. So it's basically restrictions come with pros and cons for sure.
Yeah. Plus, of course, dialogue is also for us one of the most natural forms of interaction. So in situations where we do want to interact, as in our real life, maybe dialogue is one of the best options. Whereas there may be other situations where we just want to do recurring tasks, and then it's not the best to have an open, free dialogue.
Absolutely. So if you want to focus on a particular task, I mean, you can see that at universities as well. Or if you go to math lessons, the whole reason why we do algebra is that we actually just learn a controlled vocabulary, so that later when we talk about more complex things, we can use that controlled vocabulary to explain really efficiently. I was listening to a lecture by Terence Tao, and I understood maybe 30% of what he said, simply because the rest of the vocabulary that he used is not vocabulary that I use. So it was very deep stuff about algebra. Good fun, but yeah. So those are the pros and cons of controlled vocabularies, right? Yeah. But we are very proficient actually at building those, and especially in the area of the sciences, we do that all the time.
Okay, so it also seems to me then that it's also some kind of scaffolding. Would you call it scaffolding? To me, it came just that it might be a scaffolding. If you present people with certain kinds of questions they can ask, it's some kind of scaffolding because. Yeah.
I mean, it does limit the types of questions that you can ask for sure. So hence, yes, I would also suggest that it is, but I would call it more of a free form of basically a limitation or a definition of the types of scaffolding processes that can actually occur in the communication. And by having both parties knowing that, it simply leads to faster interaction.
Okay. So thank you so far for this introduction. I would now like to delve a little bit deeper into the questions, what large language models actually are, and what they can do, and exactly into the question if they are capable of co-construction or not. So I think you both have been part of an interest group in the TRR that looked into the details, into more detail, whether or not LLMs can actually co-construct. So yeah, what have you found so far? What are your insights?
So the study is not fully done, but the actual user study is meanwhile done. Maybe to shortly give a recap of this, the goal of the study was to see with the LLMs that we have today and in the way that normal people, let's say not computer science experts, would use them, how well can we actually realize co-construction there. So we asked human participants to interact with two versions of an LLM, one that is only told, look, you should explain something to a user on the topic XYZ, but not giving any more instructions. In the second variation, we also tried to give in the background, not visible to the user, some instructions of how to co-constructively shape the interaction process, taking some of the ideas from our TRR. And then we asked the participants to talk for maximum 15 minutes with either of these. They didn't know which one, on three different topics. One was sleep, one was black holes, and the last was this game Quarto, which is very popular here in the TRR. Then asked them afterwards, before and afterwards, asked them some questions on the topics to test their understanding. And we also asked them a bit on how they perceive the behavior of the system they worked with. We are still now, sorry for the long answer, in the evaluation of the results. Some first insights. Definitely both versions helped to notably improve the understanding on the explainee side, as far as we can measure this. There was a slight gain from the co-constructive idea, not such a too big of a gain that doesn't speak against our TRR, but more about the limitations of what we can do with prompted LLMs. Yeah, some other results, but we will see later.
But thanks. That's really interesting. That you can at least modify also how the LLM is working into maybe a little bit more co-constructive way.
Yeah, we've tried system prompting in a lot of different settings actually, and it turns out that having the right prompt actually does help a lot. So we've looked at that also in the domains of sales, for example. Does an LLM sell an item well, or what happens if you fine-tune the prompt? And there's a difference of up to 40% in performance, where you basically measure does the customer really buy the product or not, right? So yeah, it turns out prompting is super important, but it does not seem to solve the fundamental problem of actually having to build a co-construction type situation. Yeah. And that is something we're very interested in.
Okay. And do you think, so this is probably more speculation than anything, but do you think that the LLM could actually spot when a user had not understand something?
Oh, that's a very tough one. So it turns out that humans do that using, in a lot of settings, non-verbal clues, and LLMs, at least if we think about language generating and consuming LLMs, in this case, just to be very precise, do not have access to those non-verbal clues, which basically means that it becomes very difficult for them. But one can imagine building a system that's able to ask the right questions to actually spot whether understanding occurred, or whether basically this particular round or set within the scaffolding process has been concluded successfully.
Yeah, and I actually think that's not too different from how humans would do this. Let's say if you're a teacher, sometimes you talk to someone and ask, have you understood that? And the person says, yes, of course, or doesn't at least show any misunderstanding. But later then you notice, no, the person hasn't understood anything, no? But yeah, finding the right question to ask in that moment certainly helps to get closer to this, and this is certainly also something that we could try to incorporate in the behavior of an LLM.
Okay, but that would be a very explicit way, sort of, to elicit the understanding that the person has, right? So, what have you understood? But do you also think that from the way the question, so what questions are asked next from the explainee, right? That's the person who asked the question. There you could also actually infer, right? This is going into the wrong direction somehow. But that would be a more indirect way. Do you think an LLM could catch that as well, or is that too indirect?
Well, with correct prompts, sure. I mean, I would not do that using just an LLM. I would actually use a set of LLMs, to be honest, because that would actually allow, basically give them different roles. If you think about judge-based RAG, for example, you have different basically agents, generally LLMs, having different jobs and then working together towards that task. And if you think about the way humans do that, actually we are specialized in different things, and we think through explanations using a bunch of steps, and those steps would be the judges.
Yeah, I mean, to shortly follow up on this, but mostly agree, to some extent that will certainly be possible, because of course you can get, if a human reacts with a certain question and that question is not really fitting, is not coherent to what has just been explained or so, an LLM may also get this. But yeah, the restriction to language, of course, is a strong restriction here, as Axel already pointed out. And it's ultimately also a bit based on the assumption that the explainee actually gives us some signal in written form that would really help to get to that.
Yeah. Now, in the TRR, we are arguing a lot, at least I would argue a lot, that a system that can explain and co-construct needs actually an explicit representation of the user's state of understanding. I already see Axel doesn't agree.
I would strongly disagree with that. I mean, it needs a representation, it doesn't need to be explicit. I mean, if you think about the way LLMs represent language, well, bunch of vectors, that's good enough. So I would disagree with that.
I tend to agree more with Axel, actually. So, but to elaborate a bit, explicit representations particularly help when in the process of understanding how to bring that into a system, no? To see how our expert knowledge about the world or our understanding of how the world works when we try to integrate this. However, AI history has shown that often the ultimate best step is to get rid of making things too explicit and create what we call a latent space, which implicitly holds all the connections between concepts, but allows the model also to deal with the uncertainty and imprecision that comes as part of the process.
I agree with that, but I would argue that co-construction might be such a subtle process that you will not find enough data to make an LLM learn this latent representation of non-understanding. Maybe certain non-understandings, they are obvious because they are reflected in the text layer, but there might be non-understandings that you don't see because you use the same words and it appears to be similar. But if you really look into it, and if you had a logical model, for example, of it, you would see this is different from that.
So if there is not enough data in the world, how do humans learn it then?
Because we know what we are doing. The LLM doesn't know what you're doing. They don't know the sequence and the logic of the tasks that you're doing.
You're talking about the restriction of an LLM in its current setting.
Yes.
What do you think, Axel?
Well, as I said, if we limit the type of inputs that we can take in, then we're limited in the types of tasks that we can partake in. And so we will be limited in the type of explanations that we can carry out. Having said that, though, what you're arguing for is that I need a logical representation, and I would basically say, number one, no, because you can show that the neural retrievers and neural reasoners, my apologies, actually perform better than standard reasoners when it comes to tasks where you have unprecise semantics. So we just finished an experiment where we looked at a latent representation of a knowledge graph based on formal logics and a basically discrete representation, and the neural reasoner was better because it could deal with inconsistencies introduced by humans.
I would like to answer to that,
sure,
because
go ahead.
before you said that there are specific things that are very clear how they have to be done. Like in military, you have to operate a machine, and it's very clear what has to be done. So I think there is no room for unclear semantics in this situation.
That is correct, but there a neural reasoner performs as well as a classical logical reasoner, simply because there you have crisp semantics, which means that if you think about it from the perspective of cone representations, imagine that the angle of your cone basically tells you how unsharp your semantics are. And basically, if you're within a cone, then you're within the semantic space. Well, all the neural reasoner needs to do is set that angle to almost zero. You have crisp semantics. And you can use that in your military example. But if you're basically dealing with a space in a kindergarten, kids come, they speak a bunch of different languages. They come from different families, mean a bunch of different things. Wide cone angle, and you survive. A logical reasoner fails. Very simple.
Yep. I wouldn't want to follow up in this moment on what Axel said, but to come back to the original point regarding the explicit representation. Of course, there is a truth to what you, I think, intend to say. If we are in a situation where certain information cannot be brought into the process, here, for instance, because of the restriction of modalities, then starting from an explicit representation that we give to the model is certainly the right way to go and maybe needed to achieve certain understanding. What the model internally does out of it, how it represents this, whether it is an explicit way or in a more latent or implicit way, that is something I think where I wouldn't see explicit representation as the final answer.
But that's the thing. So there's learning with multiple representation. It turns out that that's actually as far as I know, the most robust way to learn. And it seems that humans do that. So we use multiple representations of the same thing. And we have multiple cognitive agents, if you will, that are specialized in dealing with each of these representations, but they talk to each other. So if you think about the Kahneman system 1, system 2 thing, it's kind of the same idea, you just have more systems in there. So, but it turns out that you just fixing on one usually leads to poorer results.
Okay, so thank you. I would very much like to take on that,
Yeah.
but this would now be for the current state of the LLMs, and we will now look at what is still needed in order for an XAI system to become really co-constructive, although I see that you are already a little bit convinced. Thank you for now. So in your new project, CO7, you actually want to train LLMs that are capable of co-construction. So what are your ideas? How would you like to go?
Let me start maybe. So the study that we just talked about actually was meant a bit also as a preliminary study to see what is working, what is not, and from that to start on how can we improve this. So the idea of that project is, what do we actually need to teach and how to an LLM in order to enable it to follow the ideas of co-constructive explanation processes that we have in the process, together with, Axel can maybe elaborate on that soon, how to include knowledge in this or the other representation into the process in order to also enable to give adequate explanations. In a nutshell, the side on the teaching, I won't go too deep unless you ask me more about this. We think so. LLMs, as we know them today, went through a process called instruction fine-tuning. They have been taught to follow instructions. This is the reason why we can prompt them. Now we think about changing that process or extending that process in a way that they don't learn to follow instructions, but they learn to co-construct. That means they learn to understand I need to interact with the person I'm talking to in order to find out what is to be explained, what does the person know, where do we actually need to move, and so on and so forth. And by this, change the idea that what LLMs currently do, try to solve everything in one shot without really knowing what is actually behind.
Yeah, so we want to extend that with retrieval augmented generation. And the idea is really, if we think about explanation, as we said at the beginning already, explanation processes usually occur within a certain context. And the question is, how do we actually model that context? So we're particularly interested in domain knowledge, so basically modeling explicitly and also implicitly what type of background knowledge the system needs to have to be able to actually carry out such a co-construction process. And we're also interested, of course, in representing the explainee in some form, either explicit, implicit, or both.
Okay, but would that be part of the knowledge representation that you have just taught? So the RAG or the knowledge graph that you want to bring in there, that would be the problem domain, right? So if I want to know something about, I don't know, guitars, then it would be about guitars.
It would actually be more. It would not only be about guitars, it would basically also be about people, jobs, and basically all the kind of things that seem to be important to a co-construction process. What those things are is something that we need to figure out.
Wow, okay, so then you would have to make explicit in this knowledge graph what you think is important about co-construction?
No, I would have to make explicit these are things that might be helpful. And it is then the job of the RAG and of the LLM to actually spot the right sub-area in the embedding space that might actually help them.
Okay, but how could that look like? What could be important then?
Well, that's what we need to figure out. So one thing that we have looked into really is looking at the chain of thought output of systems like DeepSeek and how they actually, what they use as background, I mean, at least what they claim to use as background when they're generating an answer. And it turns out that there are a few features there that are quite significant apparently, such as, for example, a prediction of the person's job, a prediction of how well trained the person is, education level, things of the sort actually seem to play a role already in the chain of thought process of something like DeepSeek, which is the model that we studied.
Okay. So the model sort of makes, I don't know, draws
really.
assumptions about what your job, for example, is, even if you don't talk about your job.
That is absolutely correct, yes, based on the way you formulate questions.
Wow, okay. That's interesting. Okay, and that would be part of the information that you would put into the knowledge graph, and maybe it might be important to know, okay, this seems to be an educated person, come from STEM, so has sort of formal knowledge.
Well, we'll basically put encyclopedia-like knowledge. So what is a geographer? What does a geographer do? How is geography related to other disciplines? As the LLM already has a form of world model, making that more explicit and making those relationships more explicit has been shown in areas like machine translation to actually boost the performance. And we hope that with that would actually help with the co-construction processes.
Wow, that's really interesting. Where would you think you could get this data from?
So you have standard knowledge graphs like Wikidata, DBpedia, and the like, Yago, where you have between 1 and 10 billion assertions which describe the world in general, but there's also domain-specific knowledge. If you think about Bio2RDF and the like, those are another 100 billion triples or assertions which actually tell you something about the domain.
Okay, and how, or would you at all, insert knowledge that has been actually derived in the TRR? So our insights that our research has produced in the TRR, would that also be information that you would put into that system, or would you not?
Well, everything that helps would be put in. Is basically the job then of the LLM and of the RAG system, of course, to detect the portion of that knowledge that would be relevant to the corresponding co-construction situation.
Yeah. If it's about the knowledge, though, that let's say we gathered in the TRR about how explaining work, I think the core idea of our project is not to store this in external storages and then to introduce it to the system, but this is what will particularly go into the training process of LLMs. How to interpret signals of understanding and non-understanding, what interaction moves follows another, how the different phases of explanation processes play a role. These results that, for instance, are developed in the project in the first phase, these are all motivating how we actually design these co-construction fine-tuning processes in order to bring LLMs in that direction.
But most of those results, I guess, probably concern multimodality, so like gestures, facial expressions, and so on. Would you also put that into it, or?
So we would not start multimodally because this is, in my perception, already a very ambitious project. We are here at the very far front of state-of-the-art research on LLMs.
I'm just trying to challenge you.
And so, yes, one restriction we make in the phase 2, as far as this is foreseeable for now, is not to go multimodal. That comes apparently with its restrictions. Taking up the example of signals of non-understanding and understanding, we discussed that earlier. Many of them will not be accessible if we are in a text-based scenario. I do think, though, that doesn't really make what we do less relevant, because there are a lot of situations in the world where we interact with AI exactly in that setting. We sit in front of some text interface and interact. So the limitation of multimodality is also one that is justified by real-world scenarios.
And it's also something that we can consider in later phases. So there are multimodal foundation models out there that are just significantly more complex, which is pretty obvious. So let's start with text and then build it out later.
Okay. So this is about the monitoring, right? So the A projects are a lot about monitoring, but they are also about scaffolding. Would you also put somehow into it, scaffolding strategies? So there are different projects who really investigate different strategies.
I would definitely think so, because if we only have monitoring and don't do any scaffolding, then what we monitor remains fairly useless to the project, I believe. I mean, of course, the idea is a bit also from learning from real dialogues. What does an explainer do to scaffold based on what they monitored? And yes, where this needs to be implicitly informed by certain strategies, we will also see how we can encode these strategies. It's of course a bit something to explore during the project, what actually needs to be put with human supervision into the training process and what can just be learned by looking at respective dialogue.
Yeah, okay. Yeah, I see. And now I have one issue I think we haven't yet talked so much about, which for me is one very important characteristic of co-construction, but I have also learned often that for computer scientists, sometimes they don't like that, but I think you might. So the idea of co-construction for me is not just that you create meaning on the fly, right? So you have a history and you build on and you talk about like guitars, and so guitars in our conversation now have a certain meaning that is not directly the conventional meaning of guitars, but it's now sort of a joke because Axel is playing guitars and so on. So it has a very special meaning. Do you think that LLMs can already do that or will be able to do that? And for me, that would be one important meaning of co-construction, that we together have co-constructed now the meaning, the local meaning of guitar here in this conversation.
I suggest that they're already able to do that. I mean, with a long enough history, okay, let's get technical a little bit. So if you think about models like Mamba, the reason why Mamba apparently is better than transformers at certain tasks is simply because it has an infinite window. So it can actually, if you will, twist the semantics in the sense of alter the representation of the vectors that it uses for semantics, for distributional semantics. So I would suggest that co-constructing meaning, in the sense of co-constructing meaning might be pushing it further, but having a local interpretation, if you will, of certain token sequences is not an issue.
Yeah, I would want to raise a very different viewpoint on that topic, namely the question, is this really what we want? Is this the way we want to interact with AI, meaning that whatever we have said to the AI in the past, it will remember this and it will use this? Or don't we also, in many situations, want to have a setting where the AI does not remember what we did previously, but interacts with us, allows also forgetting things we've said, because they were come from a time when we didn't know how to interact.
Yeah, but we can do both, right? So if you think about having the different sessions of interactions, even using a GPT-4 model or the like, you can basically continue a conversation where there is a history, or basically start a new one where that history is not considered. And that would be the same with a Mamba type model. It wouldn't really change anything.
But what happens if in one session
Yeah.
you want to remember something from a different session, and then later you don't want to remember something from a different session? I don't think that the problem
Make
is
up
so
your
easy to
mind.
solve.
Well,
Make up your mind.
that's what we have branching for.
You see, there is still some research ahead.
I see. And now I actually came up with the last question, and that is for you. Do you think that, because the way I understood you is that you think that in the data there is already a lot of, well, latent space that can be learned, at least latent semantics, pragmatics, that the LLM actually learns. And I was now wondering, do you think that you could learn metaphors, not you, but the LLM, in that way?
Learning metaphors in what sense? Understanding what a metaphor means if...
No,
even
producing.
Produce?
Generating.
I mean, I would certainly think that this is also part of scaffolding an explanation to a user, seeing whether it makes sense to use a metaphor in a certain regard, choosing what metaphor, adjusting the metaphor if it's not going in the right direction. It's, by the way, one thing we haven't come earlier to. When we explain metaphors, we usually use very explicit metaphors, but actually language is full of metaphors that are very conventionalized, and we don't really even know that we're using this. I don't know, to give some example, if we create impact with something, that's there is certainly a metaphor, or if I defend my standpoint, there is a metaphor in it. So using metaphors in explanations is certainly important in general, and it's particularly also for AI, because to explain AI to someone who is not from AI, you need a way of projecting this to concepts that the other person can understand.
Okay, so I think, thank you very much. That was a nice final word. We have to stop here. Thank you. That was our podcast for today. We have talked about co-construction and actually again about understanding, and which is a really important capability for shaping explanations. And we have talked about the question of whether or not large language models are already the right technology to achieve this. And my guests today were Axel Ngonga and Henning Wachsmuth. Thank you for listening and stay tuned.
Thank you.
Thanks.
So much.
Bye.
Explaining explainability. Thank you for listening to this episode. If you have any questions about this topic, feel free to ask them in the comments. We look forward to welcoming you to our next episode.